Hello and a very warm welcome on behalf of NTI Audio. Today we are talking about the calibration of test instruments. Let me please first introduce myself. My name is Markus Becker. I am presenting this webinar and I'm assisted by Greg Schmiedle, our product manager. He is taking care of the incoming questions. The topics that we have prepared for you start with a global view on the so-called calibration pyramid. You're going to see what that means in a minute. We will explain some terms and definitions related to calibration, also refer to some standards and the accreditation of calibration labs. We will present you the calibration procedures that we are executing here in our company, and also say something about the microphone sensitivity calibration. We have also prepared a practical presentation for you, and towards the end I will summarize the key points of this webinar and also add some hints and tips. At the very end I will take a look at the questions that have popped in and add some more comments. I expect that the presentation will last about half an hour. So let us start with the so-called calibration pyramid that you see here on that slide. At the very bottom, this is the measurement application. This is actually you who are executing a measurement, and apparently you're very interested that this measurement is accurate and that the results are traceable. I will also explain what traceable means in a minute. So the next higher level is the calibration lab. That is the institution to which you are sending your instrument for verification for calibration. This is what we call the factory standard. Then the next two layers are the accredited calibration labs. I will also explain what that means in a minute. And the national metrological institutes, the reference standard and the national standard. Here I have plotted a couple of national meteorological institutes from India, Britain, China, Japan, France, United States, Germany. Virtually every country on this planet has such an institute, and they are responsible to make sure that the highest level, the international standard, the measures which are defined here are provided to the corresponding countries. The SI, the Système International de Mesure, that comes or has been defined in the French Revolution. The reference meter, the reference weight, all these fundamental standards are defined in that lab, and the French colleagues are taking care of that. And this is the top of the pyramid, the reference to which all the national institutes refer their own measurements. So with this pyramid, you can be sure that whatever you do here in the bottom can be traced up to the top so that every measurement is accurate and valid. Now, let's take a closer look at the terms and definitions, and we start with the so-called adjustment. That's a kind of a performance tuning. Let's assume we have a new manufactured test instrument, and we have to make sure that the provided result actually corresponds to the incoming signal. And for that purpose, we are feeding a reference signal into the device. We look at the screen, we take a look what it measures, what it displays, and then we adjust the instrument if necessary so that this displayed result corresponds to the incoming signal. This is of course not happening with a screwdriver. This is just a symbol to clarify that here we are manually or electronically adjusting the instrument in a way that it measures correctly. A calibration, on the other hand, is a pure verification. So you compare the displayed value of the instrument to the incoming signal, and you take a look, you verify whether this displayed result corresponds with a certain tolerance to the signal level, for instance, that is coming in. So the device will be calibrated in terms of verifying that it is actually doing its job correctly. There is no adjustment involved. However, when you send an instrument to us for factory calibration, then we will do both. We will adjust the instrument and calibrate it. I will come back to that procedure later. The calibration by an accredited lab is executed without the adjustment. So here with an accredited lab, we will also get this part of the procedure. There is one important term that you will find on the calibration certificate, that is the measurement uncertainty. And to explain that, I have here a sketch. You see here, for instance, this, let's assume this green line would represent a tolerance interval within which the measured value has to lie. So if I feed in, for instance, 1 volt, and this represents a certain interval on the voltage scale, so the displayed result has to be within that range. However, you always have a certain uncertainty. For instance, your signal generator is not absolutely accurate, for instance. So you have to withdraw this uncertainty, these yellow bars, from the overall tolerance, which means that the displayed value of the instrument must lie within the inner part, this red line here. That is the acceptance interval. And this fact, the situation here is described as the measurement uncertainty, the tighter value the instrument has to comply to in order to make sure that on an absolute level, you are sure that the instrument lies within the given tolerance limit. So the measurement uncertainty is the range in which the true value lies with a probability of 95%. And another very important term, I already mentioned it, is the traceability. I have been mentioning several times these external instruments that we are using for an adjustment of our calibration. So it is, of course, essential that these instruments are by themselves calibrated as well. And this calibration must be documented, and that gives us the traceability. So whatever we do with our test instrument, we can refer to a calibrated external device, so we can trace the result that we have acquired here versus the correctness, the performance of these external devices. Now, there is one more term I want to refer to, which is not directly, has nothing to do, no, it has to do something with calibration, but it is not about calibration. It's the conformity or the type examination. And the motivation or the reason why I refer to this term is that some countries, for instance, Germany, they place higher requirements on test instruments. And these higher requirements must be met if you want to use your instrument in a legally binding application. Let's say environmental noise measurement, and you have to go to court with your measurement results because one neighbor is complaining about the sound level. So then you have to prove to the court that your instrument has been working correctly. And in order to get there, you have to take 2 steps. The first one is that the National Meteorological Institute, in this case in Germany, it would be the PTB, verifies whether the design and the realization of the instrument model conforms to the acknowledged rules. So that means the PTB verifies the design of the test instrument itself, not of a special device, a single test instrument, but the fundamental design of that instrument is verified. And if that verification is granted, then the PTB insists that the status, the production status, the firmware, the hardware, and the software are freezed. So there must not be made any change to that instrument or to that model, unless otherwise it would lose its type approval. So these type approved instruments, initially type approved, must also be sent regularly to accredited calibration labs for calibration. So with this procedure, you make sure that your instrument is working properly and that you can use the acquired results in a court case as an example. Some words about standards and accrediting bodies. We as NTI Audio, we are offering the so-called factory calibration. This might be an individual calibration of an analyzer, of a microphone, whatever. Or we can also execute that calibration on a sound level meter. So for instance, the XL2 plus a microphone as one unit. And the next higher level would be the IEC 61672. This is an international standard for electroacoustics sound level meters periodic tests. So we as NTI Audio, we can also execute a calibration according to this procedure. This is an internationally valid standard. Then there is another standard, the so-called ISO 17025, which refers to the calibration laboratories. So if you are looking for an accredited calibration lab, make sure that it complies to the ISO 17025. One question that is forwarded to us many times is whether we as NTI Audio are accredited. The answer is no, for different reasons, but we do comply, we do follow the procedures defined in this standard. So we are maintaining a very high level, although we are not accredited. Which international bodies are accrediting labs? We have here the ILAC, the International Laboratory Accreditation Corporation, or national bodies. I have just named a number of them here. So this is something that you have to look up in your corresponding country, who is responsible for accrediting a lab. Now let us take a brief look on the procedure to execute the calibration. The first step is you have to register on our website, get an RMA number, then ship the device to us. You receive the shipping information, the address via this procedure. Then as soon as the instrument arrives at NTI, we are inspecting it. We will find out whether possibly a repair should be executed. In that case, we will, of course, come back to you and tell you about the costs or the consequences. Then we will actually execute the calibration and issue also, of course, a calibration certificate. It's up to you which type of certificate or which type of calibration you prefer, and then return the instrument to you. Now let us take a closer look on this red part here on the calibration itself. What happens here? The first step actually is that we will execute a or a firmware update if necessary and if compliant to the type approval, of course. Then we will do an initial calibration. So we will calibrate the instrument, we will verify the status of the instrument and save the acquired data as the so-called before data. Then we will do an adjustment and execute a second calibration, which gives us the after data. So there might be a difference between the before and the after data in case that the adjustment slightly has changed this performance of the instrument. And this before data here might be interesting for you, especially if there is a major problem with the instrument, which happens very rarely, but it can happen. In such case, this before data will give you valuable information to identify whether the last measurements that you have executed before sending the device to us need to be reviewed because there has been some problem. Which tests are executed depends strongly on the device that you're sending us. If it's just an electric, an analyzer or a signal generator, we do a full electric performance test with dozens of parameters. I didn't list them here. If you send us a microphone, we will verify the sensitivity, the frequency response, and the self noise. And if it's a sound level meter, so for instance, the XL2 plus microphone, We will do, again, the microphone sensitivity, self-noise, also the electrical self-noise of the instrument, acoustic calibration of the frequency response, and the electrical calibration of the frequency response. So a couple of tests are executed here. What do you need, or what do we need for a full calibration? We need an anoic chamber, which we have here in our company. Could also be, of course, in a calibration lab. This is the one we have here. Then the second important part is you need a microphone calibrator. This is the device that allows you to adjust the sensitivity of your microphone. This is also required in if you use your device, your sound level meter in the field. And let me give you some more information on that. There are a couple of impacts that may change the sensitivity of your microphone. For instance, the humidity or the ambient temperature, or if there are fast changes in the barometric pressure that might also have an impact on the sensitivity, or mechanical issues like dust or even a damaged membrane. So in order to verify whether the sensitivity, the microphone sensitivity, which plays a key role in the measurement, is correct or not, you have to do a microphone sensitivity calibration or verification. So what you do is you put your microphone calibrator onto the microphone and execute the corresponding test. Now here we have two different cases. The one is that you just verify the sensitivity and you see, okay, it's within the tolerance, it's fine. Sometimes it is required to adjust the sensitivity. You can do that with our instrument. The sensitivity is saved on a chip within the microphone, but possibly you have to override this sensitivity with a new value. Unfortunately, it is not that easy to tell you what to do in which situation. That depends strongly in which country you are, which is the applicable national standard. Maybe there are some best practices corresponding to the application you're executing. Maybe there are different rules for room and building acoustic than for environmental noise measurement. This is something that you have to find out when to do sensitivity calibration, or when optionally even adjust the sensitivity in the field. Well, I'm here now at my practical presentation, and as I cannot show you anything here from the room in which I am now, from where I'm doing my webinar, I have recorded a small video, which I will replay and comment to you now, and that shows you the procedure of a calibration. Well, this is our anoic chamber. You can see me here now doing a calibration procedure. First, I plug the microphone onto the test jig, and I put the microphone calibrator on top of the microphone. You can see that here. I start the procedure, the test procedure. The microphone is, of course, connected to an analyzer. You see left of the microphone, I have a reference microphone, a high precision reference microphone, which I need for the for the next part of the test. So as soon as this sensitivity calibration is completed, I remove the microphone calibrator, and now I can lift the test jig to a defined distance in which it is positioned towards the reference speaker, which you see up here. Now, in this part of the test, the frequency response, the acoustic frequency response, is verified. Now, this is just a short excerpt of the software that execute these tests. In reality, this takes much longer, but you can see stepwise here, this is the verification of the frequency response of the microphone. Well, when this procedure is finished, I lower the test jig again, I remove the microphone, and now together with the test instrument, I first of all, I put the microphone into this second test jig. This is to verify the self noise. So in that box in here, there is extreme silence, and that allows us to identify the internal, the inert noise that is generated by the microphone itself. Now taking the device to the outer part of the lab, here I connect it to an XL2 and I start the calibration of the electric performance, the electric parameters. This takes again time, so this is just a short excerpt here, and at the very end I get this yellow window here where I can enter the data from the device, from the customer, in order to print out the calibration certificate. So this short video was just to show you the calibration procedure. Now let us get back to our presentation and summarize. We have different types of calibration. We have the calibration of an analyzer without microphone, which gives us a certain certificate, or we can do here the sound level meter calibration according to the mentioned IEC standard. The content of the certificate starts always with the device information, the serial number, the version of the firmware, all this information. Then, as stated before, you will find the before data in that certificate. You will find the after data after the adjustment. You will find information about the measurement uncertainty and also on the traceability. So all the secondary, the external instruments that are involved in this procedure will be plotted on that calibration certificate. I can show you that in practice briefly. This would be the manufacturer's calibration certificate of an analyzer, which you can see here. Find also the date when it was calibrated and the this information I just mentioned before. Here, the before data, the actual data, whether there has been any change in between. Test conditions, the ambient temperature, humidity is also very important. Here you can see the traceability, the equipment that has been used, when it has been calibrated, according to which standard, and so on and so forth. So all this information is provided in this certificate. And the second example, the IEC certificate, is a little bit longer. So here we get more information, much more detailed, all the information, especially from the calibration procedure of the measurements that have been executed in detail for every frequency down here, and so on and so forth. So you get a full bunch of information about your instrument with this calibration here. Good. So some last hints. How frequently do we recommend to calibrate your instrument? Actually, we would recommend to do it once per year. There are some standards, some national standards who define other calibration intervals. So this is something that you have to find out for your application, for your instrument, what is applicable. Yeah. At latest, if you notice that something is wrong with your instrument, we strongly recommend to send it to us to make sure that it is verified. Which type of certificate do you need? If you send us the XL2 plus microphone, we recommend the sound level meter calibration according to the IEC 61672. Otherwise, if you send us an individual device, an MR Pro, an FX100, whatever, we will do the separate calibration, the individual calibration. Where can you do that? Here we have listed all the subsidiaries, the headquarters here in Liechtenstein, and all our subsidiaries worldwide who can execute these calibrations. Please feel free to send it to any of these places for your purpose. Otherwise, you can, of course, also send your device to an ILAC accredited calibration lab. Just keep in mind that they can only do the calibration, no adjustment, but in some cases it's even mandatory that you send it to such a calibration lab, as I mentioned before, for the type approved instruments. Well, I'm at the end of my presentation. I will take a look at the questions that have popped in just in a minute. Before, I would like to give you 3 more hints. If you want to know more about calibration, please visit our website, which you have plotted up here. You will find all the information for the procedure. Here we have the list of contacts of the our partners worldwide. And as stated in the beginning, you will find the recording of this webinar on our website under this address. Me from my side, I want to thank you very much for your interest. I hope I was able to respond or to answer most of your questions, and I would be happy to welcome you again at one of our future webinars. For the time being, thank you very much for your attention. Have a good day and bye-bye.